Hello everyone. We continue to study the Z-domain analysis module of discrete systems. Today, we come to study the sixth part, Z-domain analysis method for discrete systems. Today, we will discuss the convergence domain of the Z transform. The first question. Let's look at the definition of the convergence domain. For any given sequence x of k, such a formula that enables x of k to satisfy the definition of Z transform. The set of all converged Z domains is called the convergence domain. Then, if expressed by an expression, it is such a formula. Absolute convergence is required, then corresponds to such an area. We use ROC, the convergence domain, to describe. Pay attention to its Z transform in different sequence x of k. Due to the difference in the convergence domain, may correspond to the same Z transform form. Therefore, when determining the sequence Z transform, we must specify the convergence domain of the sequence. Then, for the problem of determining the convergence domain of sequence, there are usually two ways. One is ratio judgment method. The other is root value judgment method. Let's first look at the first method of ratio judgment. If there is a positive series, we make ρ equal to the ratio of these two. At this time, through the corresponding analysis, we found that when ρ is less than 1, the sequence converges. So, this corresponding area is the convergence domain where the Z transform exists. T does not exist in the other two cases of Z transform. Similarly, for the second method, the root value judgment method, we also set ρ for a positive series. The form equal to this limit. Through proof, we have found that when ρ is less than 1, the sequence converges. That is, the corresponding region at this time is the convergence domain of the Z transform. Other cases where ρ is equal to 1 and ρ is greater than 1, sequence does not converge. Then it means that the Z transform does not exist. In the following, we will discuss the problem of the Z transform convergence domain in several situations. In the first case, the convergence field of a finite length sequence. In the second case, the convergence field of the right sequence. The third case, convergence domain of the left sequence. The fourth case, convergence domain of bilateral sequence. In the process of analysis, we will take finite length sequence, Carroll signal, anti-Carroll signals, and bilateral signal as examples to discuss the characteristics of its convergence domain. Let's analyze the first situation. the collection of finite line sequence. We give a sequence x of k. Its starting serial numbers are as follows. K is defined in the range from -2 to 3. We find the z-transform of this sequence. According to the defined expression, you can find when the serial number takes a negative value. For these terms, the modulus of the convergence domain z is less than infinity. When k is equal to 0, it is a constant. The convergence domain is the entire z-plane. When the z-value is equal to a positive number, the convergence domain of these terms is that the modulus of z is greater than 0. According to the total three common areas, the modulus of the convergence domain z is greater than 0 and less than infinity. That is, the area where 0 points and infinity points are removed on the entire z-plane. This is the characteristic of the convergence field of finite length sequences. Let's look at the second case, convergence of the sequence on the right. We give a unilateral exponential signal, a form of Carroll sequence. Analyze its z-transform convergence domain. We bring it to the definition of z-transformation to solve it. For such a sequence, you can see that when the modulus of a divided z is less than 1, this sequence converges to z divided z minus a. This is the result of our collation. Then the convergence domain at this time. You can see that the modulus of z is greater than a, which is an area outside the circle. Then we look at a specific example. Find the convergence domain of a given sequence x of k. According to the analysis of ordinary meaning just now, we bring in specific values to solve. For such a sequence discovery, when the modulus of 3 times z is less than 1, the sequence converges to this area. Then it means that the modulus of z is greater than 1/3 as its convergence domain. You can see from this picture, for this case of the right sequence, especially for this special Carroll sequence, convergence domain is outside the circle, which is the gray area. Such a region outside a circle with a convergence radius of 1/3. Then we analyze the third situation, the left sequence convergence. We give an anti-Carroll sequence and discuss accordingly. Bring it to the definition of the z-transformation for analysis. We need to do variable substitution. Let m equals to minus k. Take this formula above. Perform the analysis. After a series of analysis, you can see the final result. When the absolute value of z divided a is less than 1, sequence convergence. It converges to a region like z divide z minus a. Then the convergence domain at this time is that the modulus of z is less than a, which is the area within the circle. We gave a specific sequence. You can take a look. We gave the left sequence x of k. Analyze its convergence domain accordingly. According to the above analysis process, you can see when the modulus of z divide 2 is less than 1, the sequence converges to minus z divide z minus 2. Then the modulus of the convergence domain at this time is less than 2. As shown in this figure, the convergence radius is 2. The area inside such a circle, that's within the red area. You can see the above two situations. The convergence region of the sequence on the right is the area outside the circle. The convergence region of the left sequence is the area within the circle. Then, according to these two situations, let's discuss the fourth type of bilateral sequence convergence. We give a bilateral sequence, consists of chiral sequence and anti-chiral sequence. Then everyone knows through the above analysis, the convergence domain of the chiral sequence is that the modulus of z is greater than b. Convergence domain of anti-chiral sequence. The case where the modulus of z is less than 1 divide b. Then for bilateral sequences, it has two values. One is the value range of b between 0 and 1 as shown in this figure. This is the first situation. Another situation is greater than 1. This sequence is the case of such a bilateral sequence. Then we analyze these two situations. Since it is composed of chiral sequence and anti-chiral sequence, then its convergence domain is the common area of the two sequence convergence domains. At this time, we consider the problem of the common area of b and 1 divide b. Then we can find when b is between 0 and 1, there is a common area. That is, the modulus of z is greater than b and less than 1 divide b. Under these circumstances, z transform of bilateral sequence exists. Then the convergence domain is a circular area. In the case where b is greater than 1, there is no common area in the convergence domain. Therefore, the z transform does not exist. For such a situation, let's look at a specific example. We give a bilateral sequence, consists of chiral and anti-chiral sequences. Based on the above analysis, you can see its convergence domain is a ring-shaped area. That is, a red circle with a radius greater than 1/3 and less than 2. Then through this example, you can see its convergence boundary does not include the pole of this z transform in the location, and the poles correspond to the boundaries of the convergence domain. According to the above four situations, we summarize the problem of the Z transformation convergence domain accordingly. As you can see, generally speaking, the convergence domain for the Z transform corresponds to an annular area centered on the origin in the Z-plane. Then, its general case is that within the convergence domain does not contain any poles. The poles correspond to the convergence boundaries. So specifically, for a finite length sequence, the convergence domain is the entire Z-plane. It is possible to discuss 0 points and infinity points. The convergence region of the sequence on the right is the area outside the circle. The convergence region of the left sequence is the area within the circle. Then, for a bilateral sequence, it is a circular area. These are some characteristics of the Z transformation convergence domain. Everyone needs to master all of this. Thanks. That's all for today. Thank you for listening.